All right, for this last one, we're talking about position versus, or second to last one, excuse me, we're talking about position versus time graph first. What does the slope of a position versus time graph tell you about an object? If you look over here on this little table, this is a good thing to know. We know that the slope of a position versus time graph is actually the velocity of our object. So let's use the rules of position versus time graphs to analyze this graph. In a position versus time graph, the first question is asking us about an object being at rest. And we know that in position versus time graphs, at rest is a flat line. The first moment that the object is in a flat line would be 10 seconds. And that lasts all the way until 15 seconds. That would be the first moment this object is at rest. And if you look here, this object is actually not at rest again. Number 36, what is the object doing from 0 to 10 seconds? We see a flat line. Remember, curved lines represent acceleration while flat lines represent a constant velocity. So this object, as it travels from 0 to 60 meters, is traveling with a constant velocity, which means it's not speeding up, not slowing down. It's just consistently going one velocity. And then number 37, what is the position of the object at 30 seconds? All we have to do to figure out position is note where on the y-axis our point lines up with. So at 30 seconds, it's right here at the 0 meter mark. So number 38 is asking us about the velocity of the object from 0 to 10 seconds. We know to figure out the velocity, we need to do the slope. And slope is equal to rise over run. When we look here, 1, 2, 3, that's up to 60. So 60 would be our rise, and our run would be this section right here, which is 10 seconds. So our slope of this object, or our velocity, would be 60 divided by 10, which comes out to be a velocity of 6 meters per second. If you look here, that says that in 10 seconds, it's moved 60 meters. 10 times 6 is 60. So that actually checks out. Let's describe the motion of this object from 30 to 60 seconds. So we're talking about this chunk of time here. At 30 seconds initially, it's got a negative slope, which means it has a negative velocity. So from 30 to 40 seconds, it is traveling in the negative direction, and its velocity we can actually figure out if we wanted to. So the rise is negative 40, and this happens over 10 seconds. So it's traveling in the negative direction with a velocity of negative 4 meters per second. It then turns around and travels for the next this looks like 15 seconds, so from 40 to 55 would be 15 seconds, in the positive direction. So from 40 to 55, it's going in the positive direction. Again, if we were to figure out the velocity here, we know that the rise is going to be 40, so a positive 40, divided by our run, which is 15. So our velocity comes out to be 40 divided by 15, which is 2.67 meters per second.